Good afternoon, everyone. Let's get started. Today is the first day of data structures class. So I'm going to introduce some course logistics and what we're going to talk about throughout this semester. These are what we're going to talk about today. First of all, I would like to tell a little bit about us and then move on to course topics and then course logistics and summarize this first lecture. First of all, about us. My name is Uihwan Kim, and my office is SC11. And if you need to contact me or have inquiries about the course or anything related to your school life or uni life, please feel free to contact me through phone or email, whatever is okay. And I am an assistant professor at the AI Graduate School since 2021. And I am leading the Autonomous Computing Systems Lab, ACSL. And these are some research goal we are aiming at our lab. We want to implement and design AI for intelligent systems to make human lives better. More specifically, we try to make AI systems for multimedia systems and robotics. Regarding multimedia, we design interaction systems, and we also work on 3D computer vision, and we develop service robots. This is one example of interaction design. On this empty touch screen, you just imagine your keyboard and just type, and it will just decode your typing, and you'll be able to enter text without keyboard layouts. And this illustrates some of the mental models of users. As you can see here, each person has a very distinctive typing pattern. However, it is quite consistent. Therefore, we can implement and develop a decoding system. This is one example of interaction design. And in this system, you just need to type with your 10 fingers. And this is for iPad or tablets. And this interaction design is for smartphones. You type with your 2 thumbs. And another thing you need to notice here, is as you give more input, the decoding accuracy improves. Because as you give more context, then it can utilize those context to decode your touch input. Okay, so this is another example of interaction design. And the third one is writing in the air. You just stare at the camera and just write with your index finger. Then this system will decode what you're writing. Okay, that was about interaction systems. And in our lab, we also work on 3D computer vision. This is one example. It's called 3D scene graph. It's about describing the surrounding world for robots or intelligent systems. What it does is it captures the surrounding environment in the form of a video, and it constructs this type of graph where a node represents an object, and the edge between these objects represents the relation between objects. So in this case, one node might be this notebook or laptop, and the other node might be a desk. And the relation between these 2 objects is going to be on, because this laptop is on this desk. And why do we need to construct this type of 3D scene graph? After constructing this environment model, then robots can do very useful tasks, like cleaning up this room. Without this 3D scene graph, this robot needs to recognize these cups, and it's very hard to distinguish this cup from this cup. However, with 3D scene graph, we can just say, oh, clean up the cup on this table. Then this robot can process what I commanded using 3D scene graph. And 3D scene graph helps the process of task managing. Okay, that was about 3D scene graph. And this is called SimVidis, Simultaneous Visual Odometry and Depth Detection and Instance Segmentation. This algorithm takes 3 input images, a consecutive 3 input images, and it generates the semantics. So what this object is and what that object is. Furthermore, it evaluates the depth of this input image. And it also calculates the relative pose between these 3 images. As you can see here, the depth map is very concrete. You can even count the number of people using this depth map. It's about extracting 3D information from this 2D image. And I also work on service robots. In this algorithm, this robot learns my behavior. So my behavior is taking a cup from this fridge, drink water, put the cup on the table, and throws this cup away. After this robot learns my behavior pattern, when I do some actions, then it recognizes my behavior pattern and provides service. So this is one of service robot applications, learning human behaviors and provide services for humans. And I also work on this unmanned robot. It could go around this area and possibly provide good services for humans. Okay, this is another robot system that we set up at GIST. Okay, this video is not working. So when the robot goes around the environment, then it captures the surrounding environment with this video. And it needs to evaluate where it is at the moment. And that is called localization. Okay, I also work on this kind of tasks. Okay, that was pretty much about me. And please let me know who you are and what you are expecting for this class and what you do on your free time. Okay, stop this video and please do this survey. After this class, I'll just go through what you gave me, your ideas, your opinions, and try to reflect your opinions regarding the lectures. Okay. The next topic we're going to talk about is course topics. By the way, what are data structures? This course is data structures course. Data structures are the way programmers organize data to efficiently process information. Here, the process means storing or reading or updating data or information. And depending on how we organize our data structure, the efficiency varies dramatically. And the data structures we choose highly affect the performance of our programs. Which data structure to use depends on the type of information our program deals with. Sometimes if you don't choose the right data type, then your performance might be very, very bad. However, by just switching from bad option to a good option, then the performance accelerates. And I would like to give you some examples of data structures. This one is lists. Data is a sequential data. And we also have something called stacks. As the name says, we just keep items on top of the previous items. So we are stacking items. And another one is queues. So we are aligning a queue, right? So first one goes out first, and the last one comes in, goes out last. So this is another type of data structure. And we also have trees. So trees literally looks like a tree. So we're building this kind of tree. Okay, this type of tree. And we also have graphs. I showed you 3D scene graph that is based on this type of graph structure. We're going to implement and learn these types of data structures. They all have their own pros and cons, and you just need to choose the right one for your application. And there is no one solution to go for all. What I mean by this is list can solve some problems very well. However, for other problems, you might need to choose trees or graphs. Okay, so you need to learn various types of data structures. And why data structures? You might want to become a better programmer. In this course, we're going to talk about how we can implement the fundamental data structures and when and where to utilize pertinent data structures. I told you several times that the right choice would lead to better performance. So you need to learn which data structures might fit in your application, okay? And sometimes the fundamental data structures might not support your applications. In those cases, you need to design your own data structures. We're going to talk about how you can design your own data structures. And it is essential for your future career. When you do research, you need to do prototyping, or you need to design your experiments or do your experiments. Or you might don't want to do research. However, you just want to go to companies. And in the job market, as you might all know, they conduct coding tests or coding interviews. And good and bad programmers and this is to distinguish between good and bad programmers. So many labs or job markets, many companies, big tech companies conduct coding tests because they want to know if the applicant is a good or bad programmer. And what are the differences between good and bad programmers? In other industries, the productivity difference between good and bad engineers is just about 2 times. However, in computer science, the gap can reach around 28 times. Why is it so? And Google's vice president mentioned that one top-notch engineer is worth 300 times or more than the average. For other industries, even though you're a very good engineer, it takes some time to make something, to make the product. However, in case of computer science, what you just need to do is imagine what you want to design and just type, that's all. So it's like art. You just need to come up with the idea. However, if you cannot come up with the idea, then you might not be productive. Okay, so it's about in other engineering field, you just spend much time, a lot of time. However, in computer science, it's like math or art. If you cannot imagine something or you cannot come up with the new idea, then it doesn't matter how much time you spend on it. And long story short, this course is to help you become good programmers. And I would like to give you some tips. Programming is similar to learning another language. We also say programming languages rather than computer science. And one of the best ways to learn languages is simply memorizing. And I would like to give you this example. 가방은 멀리 떨어져 있다. 친구는 저 멀리 있다. So Koreans can tell the answer right away. Like, which is the answer? 가방. In this case, 은 is the answer. And in this case, the answer is 는. We don't think about the grammar or any other things. We just know the answer. However, there are grammar rules that determines between 은 and 는. If there is a 받침, then we should use 은. If there is no 받침, then we should use 는. However, we Koreans don't think about the grammar. We just know. And that should happen to programming. What I mean by this is, if you are not familiar with programming, or this is your very first programming course, you better first, you need to understand how to write some code blocks to solve problems. And you can get these ideas from lectures, okay? So it's similar to understanding the grammar rules. And after that, you need to memorize the whole solution. And you need to do this job on your own. After you understand the grammar, you need to have a look at a lot of examples and memorize many of them. And this memorizing means you could write the solution code on an empty file or sheet, okay? And after memorizing possibly 50 questions, then you might become familiar with programming. And every week, I'm going to give you, every 2 weeks, I plan to give you one homework. And each homework contains around 7 to 10 problems. And if you memorize all the homework problems in this course, then you might become very good at programming. I'm sure about that. Okay, that was some tips to become good programmers if you are starting programming. Okay, next, let's talk about course logistics. In this course, we're going to use Python. It is well known for good usability. The grammar is very intuitive. It's quite similar to natural language. And because it's similar to natural language, it guarantees high productivity. You don't have to do compilation or code aggregation. You don't have to do those jobs because we are using interpreter. And it also offers very good data abstraction and provides default modules and etc. And it is very science and engineering friendly. nowadays, many people want to study data science or AI or statistics. In those fields, you might use Python or R. And R and Python are quite similar. So if you know Python, then you can use R right away. More precisely, we'll use Python 3. We're not going to use Python 2. The difference between Python 2 and Python 3 is not huge. However, there is going to be no more updates for Python 2. In Python 3, we have better performance. I told you that Python is good usability, high productivity, and science and engineering friendly. However, it's slightly slower than C++ or C. However, Python developers are trying their best to improve the performance. And nowadays, Python 3 is quite fast and it is very usable. And we're going to use Google Colab as our development tool. It is an online code editor and it offers interpreter. And you don't have to do compilation or other jobs. We just write the code and run the code on the browser. And I'll show you how to use it in a moment. So it looks like this. So let's first show you how to use Colab. So you first go to your Google Drive like this. And here you can click this new button. Okay, new button. And the Colab might not show up here. In that case, you click 더보기 or more. And here you have Google Collaboratory. And click this one, and it will create a new Colab. And you just write down your code here. And you click this button on the left, and it will just execute this Python code. That's all you need to do. Okay, you don't have to install Python 3, or you don't have to compilation, any other job. It will just show you the execution result. Okay. Okay, that's how you use Google Colab. All right, prerequisites for this course. Formally, the prerequisite is GS 1401, but it doesn't really matter. I just assume that you know some programming, or at least you know what programming is. You don't have to know anything. Perhaps some mathematical experience, like discrete mathematics or calculus, just some mathematical experience. And because you are GIS students, I'm sure that you all have this amount of mathematical experience. And you just need a laptop or desktop with an internet browser because you are using Google Colab. Okay, that's the prerequisite. And these are some comments from last semesters. Some students told me that the course was a little bit fast. And I talked about a lot of stuff. And last year, I tried some different formats of class. And some students preferred different types of lecture format, like pre-recorded lecture or online lecture or face-to-face lecture. They all preferred different lecture types. Okay, so plan for this semester is as follows. Regarding the pace, I'll try to slow down the pace and explain concepts in as much detail as possible. Okay, still, I plan to cover most of fundamental concepts as last semester. Although I will slow down a little bit, but I will cover most of the fundamental concepts. And please ask a lot of questions if something does not seem clear before or after classes, or you can use office hours or can use TA sessions or recitations. Regarding the lecture format, in the first 3 weeks, I'm going to do pre-recorded video lectures. This one is also pre-recorded video. And on the lecture time, what we are going to do is recitation. I'm going to talk about what we are going to do in the recitations in a little bit later. So basically, you just need to watch the pre-recorded video on your own, on your pace, and study it. And then you come to this recitation if you have some questions, and we're going to solve some problems, okay? So for the first 3 weeks, we are going to do this lecture format. We will follow this lecture format. And after that, what we are going to do is online live lecture. Okay, this is going to be online live lecture. And recitation will be on Thursday from 7 p.m. to 8:30 with TAs. So in the first 3 weeks, recitations will be on Thursday from 1 p.m. to 2:30, which is our regular lecture time. And during the next 2 weeks, from 4th and 5th weeks, we're going to online live lecture on Tuesday and Thursday from 1 p.m. to 2:30. And because we are using those regular lecture times for online live lecture, recitation will be on Thursday from 7 p.m. to 8:30. And after that, for the last 2 weeks before midterm, we're going to do face-to-face lecture. And recitation will be on Thursday, 7 p.m. to 8:30 with TAs. And after we try out these 3 lecture types, I'll do a survey after midterm and determine the lecture format. Okay? We will choose one of these 3, or we can alternate between these 3 lecture formats. Last semester, I tried the first 2, and half students preferred the first and second ones, respectively. And some other students also gave me some feedback that they wanted face-to-face lecture. However, very small number of students wanted face-to-face lecture. And this is to improve the quality of the course and help you understand or study data structures more effectively. Therefore, if you have any ideas to improve the effectiveness of lectures, don't hesitate to contact me. If you have good ideas, please let me know. I would like to improve the quality of this course. Okay? And regarding recitations, what we are going to do is, first of all, we're going to summarize the fundamental concepts we talked about, discussed in that week. And after that, we're going to solve some additional problems like concept problems and coding problems. And of course, we'll accept questions and answer your questions, okay? Q&A sessions. If you have difficulties or hard to understand some concepts, please come to us and we'll help you, okay? Okay, that was about recitations. And what about the grading policy? Evaluation elements, although this could be changing. First of all, you need to submit homeworks. There are going to be around 10 to 14 homeworks, and that accounts for 10 points. And this semester, you need to submit a review report. I'm going to talk about these two things in more detail on the following slides. And we're going to do midterm and final exam. Dates may change, so see the schedule. And there is going to be no makeup exams except by prior approval by me for medical or family emergencies or pre-arranged university-approved absences, okay? Other than that, there is going to be no exception. And what we don't do this semester is, first of all, homework grading. You just need to submit the homework. Because nowadays we have ChatGPT or other generative AIs. So don't copy homeworks or your code from other sources, but try to solve it on your own. And if you can't solve those problems, please come to recitations or office hours. Although we have generative AIs, that doesn't mean that you don't need to study programming. If you are not an expert in programming or computer science, then you might not be able to use those tools. You first need to understand what good codes are. And when you command those generative AIs and those generative AIs come up with some codes, you need to be able to tell whether this code is good or bad. Or sometimes you need to improve the quality of the code given by generative AIs. So you need to study programming very hard. All right. So don't copy other people's code or codes from generative AIs. And majority of exam problems will be based on homeworks. Just memorizing the solution or cracking would not work because they are programming problems and there might be some differences. And some homework problems, in fact, appeared on coding interviews of Google, Facebook, Meta, or etc. Therefore, if you conquer those homework problems, it is like preparing for coding interviews. It's very important for your future career. And another thing we don't do this semester is attendance check. I'll put the lecture recordings or materials on the web, and you just need to submit review report after studying on your own. Due is 1 week after the lecture date at 1 p.m. Okay, so what is a review report? On this course website, I gave you this review report template. On this review report, you just make a copy and you summarize the session. And if something is not clear to you, and you try to find the answer on your own, like using generative AIs or searching on the app web. And if you cannot solve these problems, then please come to us and etc. Okay. If you just submit this review report, then you will get the credit. Okay. There is no strong format. Last semester, students told me that review report was very helpful to organize their thoughts and the concepts discussed during lecture. And this is not to torture you. However, this is to help you understand and follow the lecture materials. And you need to be careful that the due is 1 week after the lecture. So how do you submit this RR report? Here is a submit button. You click this one. And you can write down your student ID and your name and make it shareable. Okay, make it shareable and copy the link. And please submit the link. Okay. We are going to have around 24 lectures, 22 to 23 lectures. And if you submit more than 20 review report, then you will get the full credit. Okay. So if you just submit 20 review report, then you will get the full credit. Okay, next we have no textbook, we have lecture slides, example codes, homework problems, and tons of materials on the web. And the course website is this one. And I will upload all the materials on the course website. We don't use LMS. Sometimes it's quite slow. And submit your homeworks and collapse here. Okay, regarding the homework, I already uploaded the homework. Okay. You just follow this protocol. You just click this file, save a copy in Drive. And after that, you click this share button and submit by clicking this link. Okay, student ID, your name, and link of your collab. Okay. And you can check your submission by clicking this link. At this point, no one has submitted this homework. However, if you submit, then your time step, your ID, your name, and link of your collab will appear here. Okay, so you just solve this problem and run this test code, and you'll be able to check whether your implementation is correct or not. And you can also see some hint if you liked. Okay, this is the format. Because if it is your first time taking programming courses, then writing the code from scratch might be quite difficult. For those who are not familiar with programming, I'm giving you this template and try to fill out this small part. And as the course goes on, don't look at this hint. Okay, so that is about homework. Okay, last, I would like to talk about the honor code. The GIST honor code tells you that you should maintain the highest standards of intellectual integrity. So cheating, falsification, fabrication, plagiarism, facilitating academic dishonesty is not good. You all know, right? And I'm telling you that just submit the homeworks. Don't copy others' code. Just submit review report. I'm not going to go through your review report. If you just submit it, then you will get the full credit. Okay. So when you write review report or submit your homework, don't copy others' code or don't copy others' text. Just write it on your own. This is to help you master data structures. Okay. And any attempt, even though it was not successful, could be considered a violation of the GIST honor code. And never ask me to modify your scores, grades for no reason. It's one of the violation of a well-known Korean act, Kim-Yong-nam-법. And 1 or 2 points do not affect your grades in general. So if you just miss one homework submission due date, don't send me a message. Okay, that 1 point is not a big deal. And don't risk getting F or even facing the GIST committee for small points. Okay. All right. Today, we introduced the concept of data structures and discussed why we learn data structures. This is to design efficient programs. And we talked about the course logistics. If anything is not clear, please contact me like call me or email me. Anything is okay. Please let me know, and please let's clarify those misconceptions. Okay, thank you for your participation, and let's call it a day.